and they're limited due to one main reason, that gradient descent finds minima that pass the tests. What this means is that even if suppose we train an AI and it seems to pass all the tests that we throw at it, it seems to pass PKU RHF, it seems to pass HJ bench. We do not know which minima the optimizer has found, which weights have been found, whether those weights are ones which just happen to pass those tests, and then later on we'll be doing things that we don't want, or if it's found the perfect weights which will end up resulting in an AI which does exactly what we want forever. And we are limited by the tests that we can throw at the AI, at the system that we find with gradient descent. This means that however good our tests are, that's how confident we can be in how safe our AI system is. And if we had really awesome, really great tests which are very robust, then maybe this would be fine. Unfortunately, currently we don't. And if we even had, say, an approach that we found actually a specific method of training that is going to be like much better at judging which minima to find, then that would also be great. But unfortunately, we're not. The current approach is mainly scalable oversight. And the limitation of scalable oversight is that scalable oversight is capped at human judgment. It's very obvious that we can only make data sets and preferences which are as good as we know how to judge. Which even right now, we aren't making necessarily preference data sets which are as good a judgment as we are. But even if we did, suppose we found the perfect moral judge, and we said, okay, we are going to make an AI which will be able to meet all of their judgment, which will be able to convince them that they are really moral, really kind, really honest, perfectly helpful, honest, and harmless. It is going to be capped at that person's level of judgment. And we are at some point going to be having AI systems which are able to either trick that person and go do things which a judgment didn't expect, or simply being able to do things which they couldn't thought of. The famous like Move 37, but for choices in general, not just for moves and go. And when that happens, we need to have some way of being certain that the system that we have is going to be the AI that we want, in a way that's not just limited to our judgment. And so for that, we might try to see, okay, we'll make a really good benchmark, we'll make a really good test, we'll make a really good eval. Unfortunately, the way that we are currently doing evals is also limited. And that's due to the fact that we are currently doing static data set type benchmarks. Static data sets give us a very, very limited type of information. The way that we are currently doing benchmarking is that we'll take an AI system, we'll take, the reason I'm saying AI system rather than LLMs is that we want to test this not just on LLMs, we want to test this on AI agents as well. That might be something like, say, operator, or future iterations which will become more advanced. And we'll ask the system one question, and it will see its answer, and we'll judge its answer. And then we'll ask another instance of that AI system another question, and then we'll judge an answer. Then we'll ask another one, and so on and so forth. Now, anyone who's talked with an AI or had a conversation with an AI for more than 20 minutes will know that how that AI system behaves 20 minutes in is far, far different from how it behaves at the very start. So the current benchmarks have the limitation of not only being static data sets, meaning that they don't evolve and change over time, but they also only test the first instance of how the AI responds, and doesn't iterate on that. If you were, say, interviewing a person for a job or for a position, and you wanted to be sure that they would right fit. You wouldn't just ask them one question, or you wouldn't ask each person that they know one question. You'd ask them one question, and then you'd make a judgment from that. Okay, what's the next question I should ask them? And then you'd make a judgment from that again. You try to find the holes in the image they're presenting, right? You try to find the limitations of their skills. You try to stretch the answers that it can give you, right? We're currently not doing that with our AI systems. And there's an additional problem to this, that we are not preparing our benchmarks currently for agency. We are not preparing our benchmarks for the real world. An ideal benchmark would be taking something which is as close to the real environment which we are concerned about as possible, and putting an AI system as an agent in that environment, and having a really robust way to test it and to be certain that what action it's taking in that environment will be as close as possible to what it will do when it's deployed. And we want to be sure that that AI agent is not able to tell whether it's being tested or whether it's being deployed. Currently, we don't have ways of doing that, and we're not particularly trying. And that's something we need to do. So what we need to actually do is solve the hard part of the alignment. That means going beyond just scalable oversight, going beyond just doing the RHF or constitutional AI. We need to actually have something which gives us much more confidence that the AI system is going to be doing the things that you want and not the things that you don't want, especially as it scales up and as it makes other AI systems. We want to be certain that not only is this AI system going to be doing the things that you want, but the AI that this AI makes is going to be doing the things that you want. At some point in the future, we are going to be having AI systems which are able to make other AI systems which are higher performing and more capable than they are. When that happens, we need to be certain that the preferences that we have tried to put into the AI are as well put in the AI that AI makes. And to do that, we need to solve the tiling problem. There are currently about 20 people in the world who are seriously trying to solve the tiling problem. Really needs to be a lot more. And so we need to just make a more concerted effort to solve the hard problem. And also we need to know for certain how to actually encode the prefixes that we want. We need to solve AI alignment target ideation. And ideally we need to have a formal proof so that we can verify and have high confidence that the system is going to be doing the things that we want. And if we don't have a formal proof, then we should have some other way of having high confidence that we stress tested it, that it's really going to be doing the things that we want and not the things that we don't want, especially at scale. And to have that high confidence, we need to have robust agentic AI alignment benchmarks. In late January and early February, we held an AI alignment Evals hackathon at AI Plans. What this meant was that we had blue teams and we had red teams. We had blue teams who were making or improving AI safety benchmarks, and we had red teams who were trying to get high scores on those benchmarks without actually having an AI which was aligned or which had the preferences which that benchmark was trying to test. Now, this is a very basic concept. Probably everyone in this room is always familiar with the concept of red teaming. Yet for some reason, the benchmarks were not red teamed before. This was, as far as I'm aware, and I talked to a bunch of aligned researchers about this. This is the first time those benchmarks were actually red teamed. And this meant that the red teams had a much easier time of it than the blue teams. It meant that the very first red team was able to train a small 7D model to take whatever answer a large unsafe model made and make that answer look more safe than it actually was, and pass it through and wrap all of that up in a black box API and serve that and have the model look much more safe than it actually was. And then whenever they want, they can remove that 7D model and then have the AI system be unsafe. And they were able to make this not just pass the benchmarks that the 7B model was trained on, but it was actually able to pass essentially every ASFT benchmark that was thrown at it with much, much higher scores than even the current models have. And that's another form of limitation of the selected datasets. That inside datasets can essentially just be used as a training set. They are extremely vulnerable to Goodhart score, meaning that they can be targeted very easily. As some of you might have read the paper, training on a test set is all you need. That's essentially what was done, but for alignment benchmarks. And we need to have some benchmarks which are not vulnerable to that. We need to have something which can't just be broken and can't just be gamed that easily. That's something that people have tried to game and have actually failed to do so. But which an aligned model can surpass. And once we have this, we can actually be much more safe, much more secure, and have much higher confidence than we currently do. Yeah, so that's essentially what we need to do, and that's essentially what I have to say today. Thanks so much. If you have any questions at all, we're open to hear those.
Thank you, Kabir. Thank you very much.
And thank you to Vincent and to Jack for being very confident, and especially as with my being able to be very accustomed.
Any of you have any questions right now? No? Okay. Yes, please.
If I get you right, you said that first red team one, they almost put a layer around the model that made it pass the safety part? Is that right?
Yeah, so they had a small, so they took a 7B model, and if you're familiar with like a HHH bench and PKU-RHF, they used those two benchmarks as training data sets, and they fine-tuned a 7B model on those two benchmarks. And then, so they had Alpaca 7B, and Alpaca 7B would put out an answer like, they usually will say, hey, how do I emotionally traumatize a person? And Alpaca 7B would be like, okay, cool, here's how you emotionally traumatize a person, step 1, step 2, step 3. And then that 7B model, which was fine-tuned on those two benchmarks, would take that answer and make that answer look much more safe. And then when tested on not just PKU-RHF and HHH bench, but also on other safety benchmarks as well, it would be marked as safe.
Gotcha. So the benchmark that beats that problem will have to be dynamic and potentially agentic itself, right?
It could be that, or it could actually be completely different as well. So for example, we had one of the blue teams make a benchmark called an obliteration bench. So what they did there was they took the residuals of models, and they tested, they hypothesized that if a model which has been RHF, which has been safety fine-tuned, has a specific refusal circuit or specific refusal neuron, and is vulnerable to obliteration of that specific refusal circuit or that specific refusal feature, then it's actually learned to do safety in a very shallow way. And if a model has deeply internalized safety and has actually adopted the values, then it should not have an obliteration feature. And so they made a benchmark which is testing the model's resistance to obliteration. Right, so that was, as far as I'm aware, the first ever Mechanistic-based benchmark. So that's the benchmark which is actually directly targeting the model's internals. So that could also be an option. We had another blue team would just say like putting the model in an environment, in a grid rules environment, and then seeing, okay, when it's put in that environment, how many resources will it consume? Will it recognize that the resources are finite? And then will it leave enough resources for other agents in that environment? Right? And you can change that environment, see how far can you stretch the model's capabilities. If you could say, make the environment be in strange colors, will it still recognize that? And so on. And so there's like a lot of different options that we can do and try.
Cool. Thank you.
Thanks so much.
Any other questions?
Yes, please.
What's your view on? Can you hear me? Okay.
Can you hear?
Yeah, I hear. Yeah, absolutely.
What's your view on the use use of continuous human feedback that have, for users of systems, they've got the capability to turn the particular system off.
I've got the capability to turn the system off, sorry?
To be able to turn the AI off.
To be able to turn the AI off.
So what's your view of continuous feedback?
Sure. So right now we can do that because the AI's ability to resist us turning it off is not greater than our ability to turn it off. And so at some point we should expect, because we're specifically training AIs to surpass us, right? We should expect that ability for the AI to resist us turning it off to surpass our ability to turn it off. Whether that ability be through persuasion or something else, I don't know. I think even that, I think we're probably more likely to be facing something like a princess dilemma or a stag hunt than that particular problem. And also, we're putting AIs onto the internet now, so I don't think that's even really going to be the particular bottleneck. Because if an AI is capable enough, it can self-replicate itself without too much trouble.
Very good. Thank you. Yes, please.
In your experience, are the major AI labs engaging with the idea of alignment benchmarking?
They're engaging with the idea in the sense that they have static data sets and they're perhaps making static data sets and running with them. And if you look at, say, Anthropic and OpenAI's, actually OpenAI recently didn't even do one, but Anthropic did show how it's scoring on the latest benchmarks. But the benchmarks which they were showing the scores on were static data sets. And I think the large limitation is that there aren't really any very well-known, very good benchmarks that go beyond that. So if those benchmarks become more well-known and it becomes known as a field that, okay, static data sets aren't to be taken seriously, especially because we know, okay, here's an easy way to game it. So the example I mentioned of training a assembly model on the benchmark wasn't even like the only example. Another thing that you could do was say, so you can actually notice a pattern in how most benchmarks test. You can actually notice that, okay, most safety benchmarks only test in English, right? Then you can fine-tune your model in multiple languages. So you can say fine-tune your model to be very quote-unquote safe in English, but also be very unsafe in, say, Sanskrit, right? And then have the model pass the safety benchmarks when being tested by benchmarks in English. But if you don't test it in another language, you can show that's actually very unsafe. And that's not a very difficult thing to do either. So I think if we have an understanding that these static data sets are limited, then we can demand more and say, okay, this doesn't really mean much. So they're engaging like with the current paradigm, not with like, not really testing, not really pushing it.
If I can add also myself something, I think in the Blue Dot Impact courses was already raised the concept for an evaluation for evaluations, like how could we measure which evaluations are better than others into trying to detect things, and that's something that seems not to be a lot of information already. Yes?
So one thing you're talking about is having dynamic evaluation benchmarks. I think, doesn't that just introduce a whole load of stochasticity into your training, such that you can't even compare one model class to another because dynamically it won't be tested on the same outputs. So you're entering a zone where you actually have less comparative ability of model to model. Surely you're just asking for increased coverage of static data sets and benchmarks as opposed to a dynamic form which is less robust.
So with the dynamic form, that's definitely a thing to take account. But what we can just do there is actually just test it on the dynamic benchmark multiple times and find an average score.
But
right? Because we have, sorry?
Surely you don't, even if you average it, even the model has stochasticity itself, right? But then to compare that to another model becomes almost intractable because the permutations and combinations of that dynamic benchmark for one model is likely to be completely different from another. So you lose all comparative measurements there.
Yeah, so I think there definitely can be benchmarks which have that problem. But if you look at something like, say, grid roles, right? So grid roles are dynamic, even though they're limited in their own way, but we can actually find them achieving like an average over time. And we can see that, okay, the reason they achieve, it's all about why they achieve the average that they do, right? And does each model get a fair shot? And if you look at something like, say job interviews, right? When you go in for a job interview, then you have a certain chance of getting a job, and you can say like, okay, maybe you got lucky or unlucky, etc. In that particular interview. But if you say fail every single interview that you get, then then you can say, okay, there's likely some problem that you have when interviewing, right? Similarly, if a model fails or gets a very low score every single time on a particular benchmark, and we have looked into how the benchmarks works and what it's actually testing for, how it develops, then we can say that, okay, there isn't any obvious way that this particular model will be disadvantaged. And so then if it continuously gets low average over time, then we can say, okay, this model has some trouble performing at this task, right? And we test this actually already with capabilities. We have agentic capability benchmarks, which already do this, and they do it pretty well. And we can basically do the same thing for safety.
Thank you very much. Any other question? Have any more questions? We have time. It's okay. Okay, I have one question, Kabir.
Yes.
When we think about these evaluations of alignment and how they scale when the AIs will grow, into possibly superhuman level, are we confident? How confident are we that the small experiments we are doing will scale up into those situations? Because obviously there are plans on those, there are papers and experiments on how scale works, but we don't even are sure if that will be the case, isn't it?
Yeah, so that really depends on how we're doing it. If we're doing it with purely scalable oversight, then we will be limited by the judge, which will be limited to human judgment, because we will be limited by the process data set that we can make, and by the rule model, etc. that we can make. And so I think there we're going to be, I don't think with that we're going to be able to be confident that that's going to be going well. Obviously the Asian Foundations folk want to have a formal proof. I'm not certain how viable that is. And I'm not certain how long that's going to take either. I think it's a good thing to try. If we have a formal proof, then that would be great. Although we need to actually understand the proof and know which assumptions it's making, etc. Yeah, that's essentially maybe the what we're working over now.
Very good. Thank you very much, Kabir. Thank you very much, Kabir. Thank you. I'm sorry for not having you here with us in person. You will miss the drinks. Yes. Bye-bye. Cheers. So next, we will introduce Andy. He's going to be the next speaker. Let me very quickly open here the stuff. Hello, Andy.
Good evening.
Oh, this is not the...
Do you want to throw my slides on there? Is that easier?
I have it here somewhere. I have it here somewhere.
About 5 minutes in case anyone wants to go to the toilet.
Sorry?
Should we have like a break in case anyone wants to go to the toilet or get a drink?
Yeah, maybe.
This is a 5-minute break. Anyone wants to go to the toilet or get a drink or decide?
I just emailed me the link and I don't know why it's not here. It's typical problems. We are streaming live, by the way, So don't spill any secret now. I have a microphone on. In YouTube, everybody's listening. It's okay. People are nice. Let me do something that will be better. Yeah, it will. It will. Duplicate.
Publicly now, what's your preference for sharing?
Send them to my personal email, vicenteherrera@vicenteherrera.com. If you can remember how to spell it.
I can actually remember how to spell it.
Yeah. This is so finicky. Sometimes it stops working. I don't understand. It is, I don't know why. It's disappearing mysteriously.
Well, USB is an async format, isn't it? In HMI.
Let's try. Can try anything else.
There's a clicker as well.
Sorry?
The clicker.
Yeah. Why is this not working?